Good morning, grade 8. How are you guys doing today? Welcome to this lesson where we're going to be looking at series and parallel circuits. You will find that this document looks very similar to the one that I used in the previous lesson, in lesson 14. But what I'm going to do today is that I've made several changes to the document. Then we're going to focus on series circuit so that you guys can know what a series circuit is and what a parallel circuit is. So by the end of this lesson, we should be able to differentiate between a series circuit and a parallel circuit. We must be able to say, if I say draw for me a series circuit, you can draw a circuit that has appliances that are in series, as well as to explain how the current is measured for appliances that are in series. There I said bulbs, lamps, or for any other appliance that may be there. Also, you must be able to draw parallel circuits. So these are our objectives for today. So just look at them and try to think if you understand and recall what we did from the previous lesson and how it links to this lesson. Okay, so first thing first, let's look at what a series circuit is. A series circuit is a circuit in which components such as cells, lamps, ammeters, resistors, different appliances that we place on a circuit. Because I hope you remember from the previous lesson that we drew different symbols for different appliances that we place on a circuit. So when we say a series circuit, as exemplified here, I hope you can see that we have a cell. That one is the representation of a cell. That is a lamp. I want to touch it, but when I'm touching this thing, remember this action, block. Okay, so when I touch there, block. Okay, so what I'm going to do is, if we are looking at this, we have a cell, we have a lamp, and we have an ammeter. Okay, and these are connected one after the other. So we say they are in series. But when we compare it with this one, with the parallel one, just take a look at the series one. So we're saying that for the series circuit, you can see here that the ammeter, which is represented by an A, and the bulb or the lamp, right, and the cell, they are all in series and they're found one after the other. Whereas here in a parallel circuit, the bulbs are parallel to each other. You have a line, a circuit, a wire, right? A wire, they are on different wires. This also is a cell, okay? So one thing though that I want you guys to note is if you recall from the video, I showed you guys this video last week, and what I wanted to point out was the fact that whenever we have something called a voltmeter, which measures voltage, right? And the voltmeter here is represented by a multimeter, this one. I hope you can see where I'm touching. So if we want to measure the voltage, this is a cell, a battery. You guys call it a battery, but always know that when it's one, we call it a cell, and then when there are many, we call it a battery. Okay? So for this cell, if you wanted to measure the voltage of this cell, and we didn't know that it's 1.5 volts, we would always place, the voltmeter is always placed parallel to the device or to the component which it is supposed to measure. Okay? Gabriel, Maria, yes, all guys who are listening to this, Zoe, Simon, you guys, make sure that you are listening to this point. Whenever you draw a circuit and you want to place a voltmeter, you always place it parallel to the component which you are measuring. Okay, so if we are looking at the flow in this circuit, this is a circuit which only has a cell and a bulb. But these two, as you can tell, they are also in series because the circuit, the wire is what? It's just the same, right? The wire to which they are connected is just the same. There are no breaks where you then have maybe if we are having another wire and we're having a cell in the middle there, then we would say it's a parallel circuit. But in this case, this is actually another example of a series circuit. So if we were to say draw a circuit and you are showing remember when you draw our circuits, you don't actually draw the bulb like this. All you do is you put the circle, this one, the one, I can't touch the screen because if I touch it, it keeps showing some funny box there, right? But if I was touching that little circle with an X inside, that represents a bulb, right? So when you're drawing your circuit, when you're drawing circuit diagrams, you draw them like this. You don't draw the actual battery and the actual ammeter. You draw them this way, the way you can see on this one, right? That's how you draw them. So if we are looking at another example of a series circuit, the cell, the ammeter, and the bulb, they are all in series. And the ammeter, what does it measure? The ammeter measures the amount of current that is flowing in the circuit. Okay? So guys, I hope you can just pause. I don't hope. I want you guys to pause the video and just rewind it for a bit, listen to the concepts that I've said, and try to see if you understand. And another thing that I'll say is that in the lesson, ask questions in relation to anything that you don't understand. Right, now let's look at how we measure current. If we have, let me just show this diagram quickly, this one, that has 3 different ammeters. You can see this one, the first one, has a single ammeter, whereas this one has 3 ammeters. But observe that all of the ammeters and the bulbs, they are all in series. So when we're measuring current for ammeters that are in series, what we do is the current for components that are in series is the same throughout the circuit. The current is the same throughout the circuit. So you will find that if we say that we have, I gave this as an example of this one that is 3 ammeters, where we say there's going to be ammeter A1, A2, and A3. These are 3 ammeters, but you will find that for ammeters that are in series, if the ammeter readings are from a series circuit, then to find the total current, we must simply find the current of a single ammeter. Because the current is the same throughout the circuit, this implies that the current on A1 will be the same as the current on A2, the same as the current on A3. I hope you understand this, guys. The current, when ammeters are connected in series, the current is the same. So if A1 is 10 amperes, that means that A2 is also 10 amperes. A3 will also have a reading of 10 amperes because the current is the same for cells or for ammeters that are in series, right? So whenever you're given a series circuit, the current is going to be the same throughout the circuit. Okay, so before I continue, before I move on, another thing that I want you guys to know is that look at these 2 bulbs. These are 2 lamps which are in series, right? There are 2 lamps which are in series, and this is the cell which is providing the voltage which allows current to move. But because they are in series, what happens is that if one of these bulbs was to burst, right, if it was to break, then this circuit would break. The circuit would not continue. The current wouldn't continue to flow. So the moment one bulb goes off, the other bulb effectively also goes off because the circuit is no longer complete. Because when the electrons are moving, they are moving along this line, this wire, right? They are moving along the wire, back through the bulb, through the cell. So if one of the bulbs breaks, then the circuit is no longer complete and both lights go off. However, if we have them placed, now these are lamps that are now in parallel. Observe now that if they are in parallel, even if the first lamp A, was to break, lamp B would still be able to switch on. That's another important aspect on the differentiation of series circuits and parallel circuits. I hope you guys don't get confused by my calm voice. These things are not as simple as I am making them sound. They will only become simple when you listen to this audio or this, this is a video, yeah? when you watch this video 2, 3 times, 4 times, read the notes, understand. Okay? So when you are using a parallel circuit, even if lamp A goes off, if lamp A goes off, lamp B can still stay on. Okay? Lamp B can still stay on. So even if the wire for lamp A was to bend, the current would still flow. The current would still flow, and lamp B would still be able to switch on. And even if lamp B was to switch off, lamp A would effectively still be able to switch on. What I also did in this PDF is that we added the part where we talked about measuring the current of cells, current for cells that are in series. And the main aspect that I wanted you guys to understand there is the point that the current is affected by the number of cells. If you have one cell which has a voltage of 1.5 volts, because remember your cell or your battery is acting like the pump, is the one that is pumping and forcing the electrons to move through the circuit. So what happens is that if you increase the number of cells, the current will also increase. Okay? Provided that the wire that you are using has remained the same. Okay? So if you want current to increase, what you can do is you can simply increase the number of cells that are there. So if you have one cell, this is just an example, if we had one cell and it's providing a current of 2 amperes, you'll find that if we were to double the voltage, we might also find a doubling in terms of the current that is found in that particular circuit. So it's important to note that for a series circuit, that when we double the number of cells, we consequently also increase the current that is flowing through that particular circuit. Right. Now we have current for cells that are in parallel. I'll try and just do this as quickly as I can so that this video doesn't become too long. I've seen that when it's too long, you guys don't want to watch. How do we now measure the current for cells or for components that are parallel to each other? So if we had 2 ammeters, yes, the sum of the current in different branches is equal to the total amount drawn from the cells. That is to say A1 plus A2. So if we were to have different ammeters on the different joints, right, so we have 2 ammeters. These are now ammeters. Please observe that these are 2 ammeters. For us to find the total current that is flowing in this circuit, what we have to do is we have to say A1, ammeter 1, plus ammeter 2. You will find that we have 3 ammeters here. This is an ammeter, this is an ammeter, this is an ammeter. Because the cells, or this is a parallel circuit, for us to find the total current, we add the current from the 2 ammeters. Remember that when they were in series, we just said whatever current we find on the 2 ammeters is equal to the total current. So if we had 1.5 on one ammeter, 1.5 on a different ammeter, the total current was still 1.5. But when they are in series, the current splits. It splits, it goes onto different pathways, and then again it rejoins, and the total current again becomes 3 amperes. Remember, unit for current is the ampere. Unit for current is the ampere. Unit for voltage is the volt, V, right? Unit for resistance, the ohm. Ohm, here, OHM. That is the unit for resistance. Okay, so you'll find that what I did here now with measuring current for bulbs in series, the explanation is given here. I just added also an important part to indicate that when one bulb is removed from a parallel circuit, the other bulbs can actually remain on. Okay? This is another image that explains or that describes how when you have bulbs that are in parallel to each other. Just imagine your classrooms, like how you guys, some of you are in 8A, some of you are in 8B, then you have the grade 9s in grade 9A, and the others in 9B. You notice that the guys in grade 9A, or the ladies, whichever you would prefer, you guys can switch off your bulb or you can switch off your lights in 9A or in 8A, but the lights in 8B will remain on. The light or the switch for 8A does not affect what happens in 8B, because the bulbs or our fluorescent lights in our block are connected in a parallel manner. So even if the guys in 9B or in 9A switch on their lights, it doesn't cause the light in your classroom to switch on. If they switch off their lights, it doesn't cause your lights to switch off. You see? Because they are connected what? In parallel. If we had connected the bulbs or our lights in series, just by switching off the bulb in 8A, all the classes 8B, 9A, 9B would then also go off. So you see that it's actually important, or it's an advantage in some situations to have the lights connected in parallel. But if you then imagine when you are in the dining hall, just by switching on once, all the lights in the dining hall go on. They are able to switch on because they are connected in series. Right, so some of these diagrams, you can start practicing them the moment you watch this video, or when we're in the lesson, we will draw these diagrams. So thank you guys for watching this video. I hope you managed to understand this concept on series and parallel circuits. This is Marshall AC Kandiadu. Goodbye.